Hello, bedtime thinkers, and welcome to the Bedtime Discoveries. I am so glad you are here with me tonight. As you settle in, perhaps lying comfortably in your bed, let us take a gentle journey into a world both mysterious and beautiful. Tonight, we will softly explore the quantum world, a place hidden beneath what we can see, where particles dance like waves, where certainty fades into probability, and where the universe reveals its most delicate secrets. We will wander slowly through its ideas, not to solve its puzzles, but to rest with them and allow the mystery to carry us gently towards sleep. Before we begin, I'd love to know where in the world you are listening from. Perhaps you could write in the comments your city and the time on your clock. It's always so comforting to feel connected across oceans, across night skies. And if you enjoy this calm exploration, please consider leaving a like. And if you would like to hear more soft, sleepy discoveries in the future, subscribing to this channel would mean so much. As we begin our journey tonight, we step carefully into a world that is hidden, and yet it is always around us. This world is called the quantum world. It is not a place you can visit with your feet, nor can you find on a map. Instead, it lives beneath everything, beneath the chair you sit on, beneath the air you breathe, beneath even the light that touches your eyes. The quantum world is the world of the very small. Smaller than atoms, smaller even than the protons and neutrons inside the atom's core. It is a world that cannot be seen directly with our eyes, a world that reveals itself only through delicate experiments and through mathematics. And yet, although invisible, the quantum world shapes everything you know, every star, every planet, every leaf on every tree. Even the beating of your heart owes something to quantum rules. In the everyday world, the one we walk through each day, things feel predictable. A ball rolls across the floor, and we know where it will land. The sun rises, the sun sets, and we trust it will return tomorrow. But in the quantum world, predictability becomes softer. Things no longer behave in ways that feel certain. Instead of being definite, they become possible. Instead of choosing only one way, they rest in many ways at once. This is why physicists often say the quantum world feels strange. Not because it is illogical, but because it follows a logic different from the one we experience when we walk, when we touch, when we live at human size. To imagine the quantum world, let's take a small journey in scale. Picture a single grain of sand resting on the palm of your hand. Now imagine shrinking yourself down smaller and smaller until that grain of sand feels like the size of the entire earth. As you keep shrinking, soon you pass the scale of ants, of cells, of molecules. And deeper still, you arrive at the atom. The atom is like a tiny solar system, with electrons orbiting a nucleus. But unlike planets, the electrons do not trace neat circles. Instead, they spread like clouds, fuzzy, uncertain, always moving, always shifting. And if you shrink still further, smaller than the atom, you enter the true quantum world. Here, particles such as electrons, quarks, photons, move and dance according to quantum rules. It is like stepping into a dream where the ordinary laws of nature soften and melt. The word quantum comes from Latin meaning how much. It was chosen because in this world energy is not continuous, like smooth-flowing water. Instead, it comes in tiny packets, tiny pieces, like steps on a staircase. You cannot stand halfway between two steps. In the same way, an electron cannot hold just any energy. It must take a quantum, a step, a packet. This discovery at the beginning of the 20th century changed everything. Scientists like Max Planck, Niels Bohr, and Albert Einstein realized that energy itself behaves in chunks, and this realization opened a door to the strange and beautiful landscape of quantum mechanics. When you listen to the rules of the quantum world, it can feel almost dreamlike. Particles can disappear and reappear. They can be in more than one place at the same time. They can be connected across great distances instantly. At first, this may sound confusing, even impossible. But as you drift with me tonight, let it be less a puzzle and more a lullaby, a gentle rhythm of possibilities, a reminder that the universe holds mysteries beyond our everyday reach. Even though the quantum world lies beneath everything, you rarely notice it directly. When you pour a glass of water, you see a smooth stream. But beneath the surface, that stream is built from trillions of molecules moving according to quantum rules. When you switch on a light, the glow feels steady. But in truth, it is made of countless photons, tiny packets of light racing into your eyes. The reason the quantum world feels hidden is that when many particles gather together, their quantum strangeness blends and cancels out. At large scales, the oddness disappears. And so, your cup of tea stays in its cup, your books stay on the shelf, and your world feels stable. But deep down at its foundation, all of this order rests upon a sea of uncertainty and chance. Long before the word quantum was used, people suspected that nature might be built from smaller parts. The ancient Greek philosopher Democritus spoke of atomos, indivisible pieces of matter, for centuries. This idea remained only philosophy until the 19th and 20th centuries, when experiments began to reveal the hidden structure of matter. Light itself was one of the first clues. Sometimes it behaved like a wave, spreading out, bending around corners. But in other experiments, light behaved like a particle, hitting tiny surfaces in sharp, countable bursts. This strange duality led scientists closer to the hidden rules beneath. And so, the modern picture of the quantum world slowly emerged. When we pause and think gently about this, we realize that the very ground of reality is not solid. It is not mechanical gears turning, not little billiard balls colliding, but instead a shimmering field of possibilities, a universe that, at its foundation, is soft, flexible, mysterious. And perhaps this is not something to fear, but to rest with. The quantum world, though strange, is not hostile. It is the quiet poetry of how existence truly works. The quantum world is not only about what is small, but also about what is hidden. It is like a secret language spoken softly beneath the surface of reality. When we look at a mountain, it feels ancient, strong, immovable. But if we could zoom in, if we could peel away the layers, we would see that even the mountain is made of atoms. And within each atom, quantum particles are moving, buzzing, shimmering. Even the oldest rock is alive with quantum motion. To sense just how small this world is, imagine again the scale of things. If the atom were the size of a football stadium, the nucleus at its center would be like a tiny marble resting at midfield, and the electrons would not be little balls circling neatly. Instead, they would be like a mist, a cloud, filling the stadium, spreading everywhere at once. And smaller still, inside the nucleus are protons and neutrons. And inside those quarks bound together by mysterious forces. Each step down leads us deeper into a realm where rules bend, where certainty dissolves. This is a quantum world, a world of whispers, a world of possibilities. Part of what makes the quantum world so unusual is that it resists our common sense. At our size, things feel solid, predictable, mechanical. We believe that if we drop a glass, it will fall, it will shatter. But in the quantum world, rules are softer. A particle does not move in one straight path. Instead, it explores many paths all at once. It is as though reality itself hesitates before deciding. This is not a flaw in our thinking. It is simply a truth of nature. The quantum world asks us to let go of the need for certainty, and instead to rest and wonder. One of the most famous windows into the quantum world is something called the double-slit experiment. It begins simply. Imagine shining a beam of light at a thin screen with two narrow openings or slits. On the other side, a second screen waits to catch the light. Now, if light behaved like tiny marbles, we would expect two bright spots lining up with the slits, but instead, something magical happens. The light creates a pattern of many stripes, light and dark. This is the signature of a wave. The waves of light pass through both slits, spread out, and overlap. Where the waves meet, they add together or cancel out, creating a soft, rippling interference pattern. This is the first clue that light is not just particles, it is also waves. But the story does not end there. When scientists repeated the experiment with single particles like electrons, they expected only two simple spots. But astonishingly, the same wave pattern appeared. Even when sent one by one, the electrons acted as if each of them had gone through both slits at once. And stranger still, if someone watched to see which slit the electron passed through, the wave pattern vanished. The electrons returned to behaving like ordinary particles, as if the act of watching changed their behavior. This is the essence of the quantum world. It is a place where possibilities live side by side, until gently observed. In the quantum world, we cannot predict with perfect certainty. We cannot say exactly where a particle is or exactly how fast it is moving. Instead, we can only speak in terms of probability. It is as though nature rolls a quiet, invisible dice, not out of chaos, but out of a deep structure. The mathematics of quantum theory gives us the odds, the likelihoods, but never the definite answer until the moment of measurement. This is why some physicists call the quantum world a universe of possibilities. It is less about what is and more about what could be. Perhaps you can imagine walking through a forest at twilight. The paths ahead are faint, half hidden in shadow. You cannot see clearly which path you will take. And yet, all the paths are real. All the paths exist until your footsteps gently choose one. The quantum world is something like this. Every particle, every atom, rests in a forest of possibilities. And only when we look, when we interact, does the path become clear. Though mysterious, the quantum world is not an illusion. It has been tested again and again for more than a century. Every experiment confirms that its rules are real. Even when those rules defy our intuition, it has become the foundation of modern physics. From chemistry to electronics, from nuclear energy to the glow of stars, quantum laws explain the behavior of the very fabric of matter. Without them, we would not understand why atoms hold together, why light behaves as it does, or why the universe shines with such quiet beauty. For us, as we drift into sleep, it may be comforting to know that the quantum world is not something we must solve. It is not a puzzle demanding an answer. It is a mystery gently offered by the universe. The fact that reality is stranger than we expect is not a problem, but a gift. It means that the universe is richer, deeper, and more enchanting than our daily lives reveal. And perhaps as you close your eyes, you can feel that richness surrounding you. Each heartbeat, each breath, supported by countless quantum motions, quiet, hidden, yet always present. Every object you see around you, your pillow, your blanket, the walls of your room, even the stars above you, are built from atoms, and every atom obeys quantum laws. It is humbling to think that nothing would exist as it does without these delicate rules. If electrons were not restricted to specific quantum energies, atoms would not be stable. If protons and neutrons were not bound by quantum forces, nuclei would fly apart. If light were not made of photons, our world would be forever dark. Quantum physics is not simply curiosity. It is the deep scaffolding of reality itself. It is what allows the universe to be. We often think that certainty brings comfort. We like to know where things are, how they will behave, but in the quantum world, uncertainty is built in, and instead of fear, there is poetry. Imagine looking up at the night sky. You see a star twinkling far away. The light that reaches your eyes began its journey thousands of years ago, and yet on its way, each photon of light traveled as both wave and particle, uncertain until it arrived. And now, it becomes part of your vision, part of your dream tonight. Uncertainty is not emptiness. It is possibility. It allows the universe to remain alive, ever changing, ever becoming. Think of a violin string. When it is plucked, it does not just vibrate in one single way. It vibrates in many modes, many harmonies, all at once. Out of these vibrations comes the beauty of music. In a similar way, the quantum world vibrates with possibilities. Each atom, each particle, holds many states, and together they create the harmony of existence. If everything were rigid, fixed, certain, there would be no music. It is the uncertainty, the superposition of vibrations, that creates the melody. So, too with the universe. Why, then, do we not notice the quantum world directly in daily life? Why does the strangeness seem to disappear at larger scales? The reason lies in a process sometimes called decoherence. When many particles interact, their quantum behavior becomes entangled with countless others, and the delicate possibilities blur into a single stable outcome. This is why you never see a cup of tea both full and empty at once, or a cat both asleep and awake in front of you. The quantum strangeness is still there, but hidden beneath the weight of many interactions. It is as though a veil falls between the small world and the large, shielding us from the raw uncertainty, giving us instead a calm, dependable experience of life. For scientists, peering into the quantum world is like standing at the edge of an endless ocean. Every experiment, every equation reveals something new, and yet for every question answered, more questions arise. Is a quantum world the ultimate foundation of reality, or is there something deeper still? Do particles exist only as probabilities until they are observed, or is there another explanation? Are there hidden layers of the universe still waiting to be revealed? These questions may remain open for centuries, but they remind us of the wonder of discovery, the joy of asking, and of listening to nature's quiet reply, though it may seem distant. The quantum world is always close. Every breath you take is filled with oxygen molecules, each one obeying quantum rules as it bonds with your blood. The rhythm of your heartbeat, the spark of your thoughts, are guided by quantum processes inside the cells of your body. So tonight, as you rest, you are not apart from the quantum world. You are made of it. You are part of the same mystery that shapes stars, galaxies, and light itself. It is tempting to demand certainty, to want clear answers and firm ground beneath us. But sometimes the deepest peace comes when we accept the mystery, when we allow the universe to remain strange. The quantum world may never be fully explained, but it does not need to be. It can simply be the gentle reminder that reality is richer than our waking minds can grasp. As you drift toward sleep, you may let yourself rest in that richness, knowing that even if you do not understand it, you are held by it. Every particle in your body, shimmering softly in the quantum sea. And so, our first step into quantum world comes a gentle pause. We have asked, what is the quantum world? And we have found that it is the world of the very small, the hidden foundation beneath everything. A place where particles behave like waves, where uncertainty rules, and where possibilities live. It is not a world we can walk into with our feet, but it is a world we carry within us always. Soft, mysterious, and deeply beautiful. As we continue our calm journey tonight, we turn to one of the most enchanting ideas of quantum physics, the wave-particle duality. This gentle principle tells us that the smallest things in nature do not behave as only particles, nor as only waves, but instead they carry both qualities. Depending on how we look at them, it is as if reality itself wears two faces, sometimes solid, sometimes flowing, sometimes a speck of matter, sometimes a ripple across space. Long before the age of quantum physics, people wondered what light really was. In the 1600s, Isaac Newton imagined light as tiny particles, little corpuscles shooting straight lines into the eye, but others, like Christian Huygens, believed light was a wave. He pictured it rippling, like circles spreading across a pond. When two ripples met, they could strengthen each other or cancel out. For centuries, scientists debated, is light made of particles or waves? The answer was strangely both. In the early 1800s, an experiment by Thomas Young seemed to settle the question. He shone light through two narrow slits side by side. On the screen beyond, a rippling pattern appeared. Bright bands, dark bands, stripes of interference. This was the clear signature of a wave. Just as two water waves overlap, light waves interfered, creating patterns of brightness and shadow. Light, it seemed, was a wave. But nature was not finished with its secret. In 1905, Albert Einstein studied the photoelectric effect. He noticed that when light shines on certain metals, it can knock electrons free. But, curiously, the effect only worked if the light had enough energy. No matter how dim the light was, if each photon carried enough energy, an electron was released. Einstein explained that light must also behave as particles, tiny quanta. Each photon carried a precise packet of energy. This earned him the Nobel Prize and opened the door to the idea of wave-particle duality. So light was not just a wave, and not just a particle, but both. The mystery deepened further. If light could act like a particle, could matter act like a wave? Louis de Broglie, a French physicist, proposed that electrons themselves have a wavelength, and not long after, experiments confirmed this. Electrons fired at a crystal, spread out, and interfered just like light waves. This discovery was astonishing. It meant that everything, not just light, carries both a particle side and a wave side. Even you, as you sit or lie here tonight, are both matter and wave. Though at your size, the wave is far too tiny to notice. To picture this, imagine holding a pebble in your hand. It feels solid. You can toss it and watch it fly like a particle. But imagine, too, that as it moves, it leaves behind invisible ripples like water flowing outward. Those ripples are its wave. Every object, every particle, carries both faces. This duality is not just a curiosity. It is what allows atoms to exist. Electrons, behaving as waves, spread out around the nucleus. Their wave nature creates standing patterns like musical notes. Each note is a possible orbit, a quantum state. Without this wave behavior, atoms would collapse. There would be no chemistry, no molecules, no life. The wave-particle duality is a quiet foundation of the world we know. As you close your eyes tonight, you may let this mystery rest gently with you, that every spark of light, every breath of air, every atom in your body is both particle and wave, sometimes sharp, sometimes soft, sometimes solid, sometimes flowing. The universe does not ask us to choose. It whispers to us that both can be true. When we pause for a moment and let the thought linger, that particles can also behave as waves, it feels almost like a riddle whispered by the universe, a gentle puzzle, not meant to disturb us, but to remind us that the world is far more magical than it appears at first glance. Consider again the double-slit experiment. Electrons sent one by one should have landed as tiny dots. Yet together they built a pattern of waves, as though each electron had whispered to itself, "I will explore many paths," and then quietly decided where to land. It is not just light that carries this mystery, but the very matter that builds our bodies, our homes, our world. If we could shrink ourselves down small enough to see the waves of matter, we would not see particles floating like specks of dust. We would see something softer, a haze, a probability cloud, a presence spread through space. And only when we try to touch or measure does this haze collapse into a particle, into something we can point to, something we can say, there it is. This duality is not an illusion. It is the way the universe holds balance. The particle side gives matter its solidity, its structure. The wave side gives it flexibility, patterns, harmony. Without one, the other cannot exist. Together, they allow the universe to be both stable and alive. Think of a piece of music. It is made of individual notes, each one distinct, each one a particle of sound, but it is also made of melodies, flowing waves, overlapping, weaving together. You cannot separate the two and still have music. In the same way, matter cannot be only particle nor only wave. It must be both. Physicists have found that even larger things, not just electrons, but whole molecules, can behave like waves. In delicate experiments, molecules made of dozens, even hundreds of atoms, were sent through slits and still they spread out, interfering like ripples of water. The wave nature is always there, though it grows harder to notice as things become larger. Imagine for a moment your own body. Every atom in you carries a wave. Every breath you take ripples gently through the quantum fabric of reality. Though you feel solid, though you feel still, you are also a wave, reaching softly outward, blending with the waves of the world around you. This idea can be unsettling if we try to grasp it too tightly. But if we let it float gently, it becomes comforting, a reminder that you are not separate from the world. You are part of its patterns, its harmonies woven into the music of existence. When scientists look closely, they describe these waves not as ripples in water, but as waves of probability. They do not tell us where a particle is, but where it might be, the likelihood of its presence here or there. It is as though nature paints in watercolor. Never hard lines, but gentle washes of possibility. In this view, the solid chair you sit on, the walls around you, the pillow beneath your head, are all built from clouds of probability, layered and bound together, forming the stable world you trust. And yet, beneath that stability, there is softness, a hidden dance of waves. If you ever watch the ocean, you see waves rolling endlessly one after another. Each wave is both individual and part of the greater sea. So, too with particles. Each carries its own wave, and yet all are part of the greater quantum ocean, a universe alive, shimmering, forever in motion. As you lie here tonight, listening gently, perhaps you can imagine yourself as part of that ocean, a single ripple, yet connected to all others, a particle in form, but a wave in essence, soft, fluid, timeless. And so the wave-particle duality becomes less a riddle and more a lullaby. The universe sings with two voices, one sharp, one smooth, one particle, one wave. Together, they weave the fabric of reality and cradle us as we drift quietly toward rest. The thought that the smallest pieces of reality can be both particle and wave has guided some of the most profound discoveries of the last century. When scientists accepted this dual nature, they began to see the world in a new way. At first, it felt contradictory. How could something be two things at once? But over time, they learned to let go of the need for a strict choice and to accept the softness of both. One of the clearest places where this duality reveals itself is inside the atom. The electrons that circle the nucleus are not like tiny moons spinning around a planet. They do not travel in neat, predictable paths. Instead, their wave nature spreads them into orbitals, clouds of possibility, patterns shaped by quantum rules. These orbitals form the architecture of chemistry. They allow atoms to bond, to form molecules, to create the rich tapestry of matter that builds our world. Without the wave side of electrons, there will be no structure to the elements, no diversity, no life. And yet, when we look closely, the wave becomes a particle. An electron strikes a detector in a single place. A photon lands on a camera sensor as one sharp point of light. The universe does not abandon its waves, but it collapses them, folds them gently into a particle whenever we reach out to touch. It is as though reality itself plays hide and seek, showing us waves when we stand back and particles when we step forward. This is not only a curiosity of the laboratory, it is the principle behind technologies that surround you every day. The screens that glow in the darkness rely on photons behaving as particles. The semiconductors that power computers depend on the wave-like nature of electrons moving through materials. Even the lasers that scan barcodes or guide surgeries exist because light is both a ripple and a packet. Without the dual nature, the modern world would vanish into silence. Sometimes people ask, which one is more real? Is the particle real or is the wave real? But perhaps the gentler answer is that both are real and neither is the whole truth. The quantum world is not bound by the categories of our everyday thinking. It flows beyond them. It holds opposites together. It reminds us that reality does not have to fit neatly into the boxes of human thought. You might imagine it this way. Picture a dancer on a stage. At one moment, they are still, balanced, solid as a statue. In the next, they leap and twirl, flowing like a ribbon of silk. The stillness is real, the motion is real, and both belong to the same dancer. So too with particles and waves. They are different expressions of the same underlying reality. There is something quietly comforting in this acceptance of duality. So much of our daily lives asks us to choose, to see things as either one way or another. But nature whispers differently. It says a thing can be more than one thing at the same time. Light is both wave and particle. Electrons are both spread and precise. Existence itself carries both certainty and softness. As you listen tonight, perhaps you can let this truth rest gently within you. You, too, are not only one thing. You are body and mind. You are solid and flowing. You are present in this moment, and yet spread out in memories and dreams. Just as the quantum world is richer than one description. So are you? Some physicists describe the wave-particle duality as a paradox. Others call it harmony. But for us, here in this quiet hour, it can simply be a lullaby, a reminder that the world is vast and layered and more than it appears. Imagine for a moment a quiet shoreline at night. The moonlight dances on the water. You see the waves rolling, endless, soft, and silver. And then you pick up a pebble from the beach and hold it in your hand. Solid, still, particle, wave, both truths together in one scene. The universe holds both, and so can you. As we close this gentle keynote, we can see the duality not as a puzzle to be solved, but as an invitation to wonder. The quantum world invites us to step beyond ordinary thinking and to rest in mystery. The smallest things, the sparks of light, the breath of atoms, are both waves and particles. And because of that, the stars shine, the atoms bond, and life itself emerges. So tonight, as you drift toward rest, you may let the mystery cradle you. You may feel yourself as solid and as flowing, a particle of matter and a wave of possibility. Both true, both real, both part of the universe's quiet song. There's a principle at the heart of the quantum world, a principle so quiet, yet so profound that it reshaped everything we thought we knew about reality. It is called the uncertainty principle, and it whispers to us that at the smallest scales we cannot know everything with perfect clarity. Imagine holding a grain of sand between your fingers. If you look closely, you can see where it is, you can measure its size, you can weigh it, you can know so much about it, because it is large compared to the quantum world. But when we shrink down to the level of electrons or photons, something strange happens. The very act of looking changes what we see. The uncertainty principle tells us that for certain pairs of properties, such as a particle's position and its momentum, the more precisely we know one, the less precisely we can know the other. If you try to pin down exactly where an electron is, you lose clarity about how fast it is moving. And if you try to measure its momentum with perfect accuracy, its position becomes blurred, spread out like a soft watercolor on a page. This is not a matter of faulty tools. It is not a limitation of human technology. It is a fundamental truth of nature woven into the very fabric of quantum reality. At first, this unsettled physicists. They were used as certainty, to predicting the paths of planets, the swing of pendulums, the flow of rivers. But here, in the quantum world, certainty melted away, replaced by a fog of probabilities. Perhaps the best way to imagine this is to think of fireflies on a summer night. When you glance into the dark, you see flashes of light here and there. You know the fireflies are real. You know they are moving, but you cannot point to one and say, with certainty, exactly where it is and how fast it is flying at the same time. You can only glimpse patterns, only trace possibilities. The firefly is free to dance, just as the electron is free to exist without being pinned down by our desire for clarity. This principle, known as Heisenberg's uncertainty, is not meant to frustrate us, though at first it seems to. Instead, it offers a gentle reminder that nature is not bound to the sharp edges of human measurement. It flows beyond them, soft and untamed. When we look at an electron, we see not a marble fixed in space, but a cloud of probability, a haze that says the electron may be here or here or here, and when we measure, the haze collapses and the electron chooses a place. But the more sharply we focus on its place, the less we can know of its movement. The sharper the picture in one direction, the blurrier it becomes in the other. There is a kind of poetry in this. It is as though the universe is saying, you may know, but not everything, not at once. A gentle veil is always there, guarding the deepest secrets of existence. You might imagine standing on a beach, watching waves roll in. If you freeze your gaze on a single crest, you know where it is at that moment. But the wave's motion, its rhythm and flow, escape you. If instead you step back and watch the rolling motion of the whole sea, you understand the momentum, but lose the sharpness of each crest. You cannot hold both at once, and yet both are real, both are true. And so, the uncertainty principle is not just about electrons. It is about the way reality balances knowing and unknowing. Certainty and mystery woven together, inseparable. The uncertainty principle, though first written as an equation by Werner Heisenberg, is not just a rule of mathematics. It is an invitation to see the world differently. It whispers that nature is not rigid, but flexible, not mechanical, but living. Think for a moment of a bird in the twilight sky. If you look up quickly, you may catch a glimpse of its exact place, its wings outstretched in that instant. But in doing so, you miss the story of its flight, the arc, the rhythm, the journey. If instead you follow the bird's motion, the sweep of its wings over time, you feel the flow, the pattern, but lose the crisp memory of any single moment. The bird is both here and in motion. To know one clearly is to let the other soften. This is what the quantum world teaches us. Particles are not like tiny stones rolling along definite paths. They are whispers of possibility. And when we ask the universe about them, the answers come with a trade-off. To know more one side is to let the other fade. At first, scientists tried to resist this truth. They wanted certainty. They wanted to map every electron as though it were a planet in orbit. But experiment after experiment showed them the uncertainty was not going away. It was not a flaw in their equipment. It was reality itself, shimmering just beyond their grasp. Consider the microscope. When you shine light to see something, the light itself interacts with it. For a grain of sand, this does not matter. But for an electron, the touch of light is enough to shift it, to scatter it, to change its motion. The very act of seeing disturbs what is being seen. The closer you look, the more you blur. This is not only about particles. It is about the fabric of existence itself. The uncertainty principle places a limit on precision, a natural softness at the heart of reality. Without this softness, atoms could not exist. If electrons could be pinned down exactly, they would collapse into the nucleus and matter would dissolve. The fuzziness, the uncertainty, is what holds the universe open. It is what allows structure to form. In a quiet, almost hidden way, uncertainty makes life possible. We often think of uncertainty as something to be feared, a lack of knowledge to gap. But in the quantum world, uncertainty is not emptiness. It is richness. It is possibility. The electron's blur is not ignorance. It is freedom. It is a space for atoms to breathe, for molecules to join, for stars to shine. Perhaps you can feel that same truth in your own life. We long for certainty, to know exactly what will happen tomorrow or the day after. But life, like the quantum world, resists this sharpness. It gives us clouds of possibility, paths that shimmer ahead, but never hard lines. And just as in physics, that uncertainty is what makes life rich, what allows new things to emerge, what allows wonder to unfold. In music, the pause between notes, the uncertainty of what sound will come next, gives a melody its shape. In a story, the unknown ending is what keeps us turning the page. In love, in friendship, in journeys of the world, it is the mystery, the not yet known, that gives them depth. So, too, in physics, the uncertainty principle is not a flaw. It is a heartbeat of creation. When Heisenberg first described this principle, it startled the scientific world. But slowly, like a tide coming in, it began to reshape our understanding. It told us that knowledge has limits, and that those limits are not walls, but windows. Beyond them lies a space not of nothingness, but of possibility. So as you rest tonight, perhaps you can allow yourself to embrace a little uncertainty, to soften your hold on the need for answers, to rest in the comfort that even the universe itself leaves some things undefined, and in that undefined space, beauty emerges. The uncertainty principle is often written as a simple inequality, a small equation with symbols and numbers. But behind those symbols lies something far larger, a truth about the way reality breathes. It is not only about particles, it is about balance. The universe is not a machine wound tightly, where every gear can be predicted. It is a living rhythm, a balance of knowing and mystery. Imagine, for a moment, standing in a forest at night. The trees stretch upward, dark silhouettes against the stars. You cannot see every detail. Some branches are hidden. Some roots vanish into the earth. Yet you know the forest is there, alive, vast, connected. The uncertainty does not take away from its beauty. In fact, it deepens it. The mystery adds a softness, a richness, a sense of wonder. So too with the quantum world. When we try to know everything at once, position and momentum, sharpness and flow, nature refuses. Not out of cruelty, but because such total knowledge would break the harmony. If an electron could be pinned perfectly in place, its energy would be infinite. Its existence would collapse. The uncertainty principle protects the world from such extremes. It spreads particles gently, holds them in probability clouds, allows them to orbit, to bond, to create. In this way, uncertainty is not a lack, it is a gift. Some have compared it to breathing. When you inhale deeply, you know the air is entering your lungs, filling them. But you cannot count each molecule, nor trace each one's path. You know enough, but not all. The breath is real, even though its details are hidden. Life moves forward anyway. In the same way, quantum uncertainty allows the universe to breathe, to remain alive, to unfold moment by moment. Others describe it as a veil, a soft curtain drawn between us and the absolute. We may glimpse shapes through it, but never the full picture. And perhaps that is for the best. For in the softness of that veil lies room for imagination, for possibility, for discovery. If everything were fixed, certain, and known, there would be no wonder left. The uncertainty principle ensures the universe remains forever open, forever alive. And it does something else, something quietly profound. It reminds us of our own place. We, too, live with uncertainty. We do not know every detail of tomorrow. We cannot hold both clarity and flow at once. But this is not a weakness. It is a mirror of the very structure of reality. To be human is to live like the electron, part solid, part wave, part known, part mystery. If you close your eyes now and think of your own life, you may notice the spaces of unknowing, the unanswered questions, the choices still ahead, and perhaps you can feel comfort that the universe itself is built in the same way. Uncertainty is not emptiness. It is possibility. It is life unfolding. So the uncertainty principle, strange though it seems, is not a threat to order. It is a gentle law that allows order to exist at all. It is the reason atoms do not collapse, the reason energy flows, the reason time itself can carry us forward. It is not the enemy of knowledge. It is the frame within which knowledge can exist. And in that frame we find peace. For if the universe does not demand certainty, then neither must we. We may rest in the blur and the softness in the not yet known. We may trust, as the particles do, that the balance holds, that the haze of probability still gives rise to stars and planets and life. So tonight, as you let your body relax, as you drift quietly into rest, you may feel yourself floating in that same haze. Not everything known, not everything fixed, but all things possible. Just as the electron hovers in its cloud, you, too, hover in the gentle embrace of existence. Uncertain yet whole, undefined yet complete. There is a quiet truth in quantum physics, the truth that feels almost like a dream. It is called superposition, and it tells us that in the smallest places of reality, things can exist not only in one state, but in many states at once. To our everyday minds, this sounds impossible. How can something be in two places at the same time? How can it be both this and that? Yet, in the quantum world, this is not only possible, it is natural. Imagine a coin resting in your hand. If you flip it into the air, in the everyday world, it must land as either heads or tails, one or the other. But in the quantum world, before the coin is measured, it is not only heads and not only tails. It is a blend, a soft overlap, a state of both at once. Only when you look, only when you measure, does the coin choose. This strange idea of superposition is not just a thought experiment. It has been seen in the behavior of electrons, photons, even atoms. These particles can travel paths as though they walk down many roads at once. They can hold more than one truth inside them. And this is not just imagination, it is experiment, it is fact, it is the way the universe breathes. Think of music again. A note is not just a single sound. It is made of many vibrations layered together, harmonics and tones that overlap, forming richness. Superposition is like that. A quantum state is not a single sharp note. It is a chord, a blending of many possibilities waiting to be heard. Scientists have tested this in delicate experiments. Photons of light sent through devices that split their paths do not choose one path or the other. They take both. They exist in both routes. Until measured, it is as though the photon whispers, "I will not decide just yet. I will explore all paths." This principle, though hard to picture, is at the heart of what makes the quantum world so different from our daily lives. In our world, doors are either open or closed. Lights are either on or off. But in the quantum world, the door can be both open and closed, the light both on and off, until the moment of observation. Some find this unsettling. But if we listen more softly, it can feel like a lullaby. The universe, at its smallest scale, refuses to be pinned down. It allows for openness, for multiplicity, for possibility. Things do not rush to choose. They hold all options, all songs, all paths until the time is right. Perhaps you can feel this in your own life too. Sometimes you are not only one thing. You are many. You are strong and gentle. You are still and moving. You are here and dreaming of elsewhere, just like a quantum particle. You are a superposition of possibilities. And that does not make you less real. It makes you vast. Superposition is what gives quantum computers their extraordinary power. Instead of bits that are only 0 or 1, they use qubits, which can be both 0 and 1 at the same time. In this way, they can hold many answers, many paths, all at once. A technology born from the softness of possibility. But beyond the science, there is a gentle lesson. Superposition teaches us that reality is not rigid. It is not locked into a single truth. It can hold more than one thing at once. It can be layered, complex, subtle, and still be whole. And so, as you rest tonight, perhaps you can allow yourself to drift into your own superposition, both awake and gently falling asleep, both here, listening, and wandering elsewhere in dreams, both solid and fluid, both one and many. When we sit with the idea of superposition, it can at first feel like a riddle. How can something be both here and there, both 1 and 0, both existing and not existing? Yet the quantum world reminds us that what seems impossible in our everyday experience is simply natural at the smallest scales. One of the clearest ways to picture this is to imagine a soft mist floating above a meadow. From far away, the mist looks like one gentle cloud. But as you step closer, you see that it is spread everywhere at once, not bound to a single place. It is here, and it is there, softly touching every blade of grass. The quantum particle in superposition is like that mist, not locked to one state, but spread across many, softly, gently, all at once. A famous thought experiment illustrates this mystery. Schrodinger's cat. You may have heard of it. A cat, placed in a sealed box, tied to a quantum event, is said to be both alive and not alive, until someone opens the box. Of course, this is not meant to be taken literally. Cats do not live in such strange states. The story is meant to show how odd superposition appears when we try to stretch it into the large, everyday world. At the quantum level, it is natural. At our scale, it feels strange. But perhaps there is another way to think of it, one that feels softer, more soothing. Imagine a dream. In the dream, you could be walking through a forest and at the same time flying above the trees. You can be yourself and someone else. Dreams do not follow the strict rules of waking life. They allow two truths, two states to exist side by side. Quantum superposition is like the universe's dream, a place where particles hold many truths until the moment of waking, when we look. Physicists have demonstrated this beautifully. They send particles of light through carefully built paths, and when unobserved, the photons take both routes. They interfere with themselves like ripples meeting in a pond. Yet the moment we measure, the moment we ask, which path did you take? The photon chooses only one. Before that question, it was both. It was many. This tells us something profound, that reality is not fixed until interaction. Possibility lingers, spreads, lives quietly until the universe, or we ourselves, ask it to decide. Reality is not just being, it is becoming. You can imagine this as a book not yet written. before the words are placed on the page. The story could go in many directions. All those possibilities hover there, waiting. Superposition is like that unwritten story. Only when the pen touches paper, only when the page is marked, does one story take shape. Until then, many are possible. And perhaps this feels familiar in your own heart. We often live in states of becoming. Not yet this, not yet that, holding several possibilities at once. You might be resting, and at the same time imagining tomorrow. You might be quiet, and at the same time full of thought. This is not contradiction. It is richness. It is the human version of superposition. In technology, this principle is not only poetic, but practical. Superposition allows quantum computers to try many calculations at once. Instead of marching one by one through possibilities, they explore them together as overlapping states. This is why scientists dream of machines that could solve problems far beyond the reach of classical computers. And it all comes from the general truth that at the smallest scales, things need not be only one way. They can be both until we ask them to choose. So superposition is not chaos. It is not confusion. It is harmony. It is the way the universe keeps options open. It is the silence before the song begins, when all melodies are possible. It is the pause before the dream takes shape. As you lie here tonight, perhaps you can feel yourself as a kind of superposition, both anchored in the present moment and floating softly into the future, both awake enough to listen and relaxed enough to drift, both here and beyond. Just as the quantum world holds many truths at once, so, too, do you. The mystery of superposition is not only in equations or in a laboratory, it is in the way it reshapes how we think about reality. We are used to a world of choices. Light is on or it is off. A door is open or it is closed. We imagine reality as clear, definite, and separate, but the quantum world whispers otherwise. It tells us that before the choice, before the observation, the world is layered. It holds both truths at once. Think again of a coin tossed into the air. In our world, it spins until it lands. But in the quantum world, before it touches the ground, it does not simply spin. It exists in a blend of states, heads and tails, overlapping like notes in a chord. And only when we ask a question, does the chord collapse into a single note. There is something gentle in this, something patient. The universe does not rush to choose. It holds all possibilities quietly, peacefully, until the time is right. Superposition is nature's way of saying, there is no need for hurry. Let all truths rest together for a while. Physicists often describe this as a wave function, a soft mathematical cloud that holds all possible states, all overlapping realities within it. To observe is to collapse the wave function, to draw a single thread from the many. But until then, the many remain alive, humming quietly in the background. And here lies a quiet beauty. Superposition is not just about particles. It is about openness. It is about holding space for more than one truth. Just as a song can be both sorrowful and beautiful, just as twilight can be both night and day, so too can reality be both this and that. This principle is delicate but powerful. It is what allows quantum entanglement, where two particles share a connection across space. It is what allows quantum tunneling, where particles slip through barriers. Superposition is the soil for which many other quantum wonders grow. If we look beyond science for a moment, perhaps we can see a reflection of superposition in ourselves. There are times when you are both strong and vulnerable, both certain and uncertain, both rooted in the present and reaching toward the future. This does not mean you are broken or divided. It means you are whole, complex, layered like the universe itself. There's a comfort in knowing that the smallest things do not rush to decide. They hold both until the world calls for one. And perhaps we, too, can give ourselves that gentleness, to rest in the both, without needing to collapse too quickly into one choice. In dreams, this truth is clearest. In a dream, you can be here and there. You can be yourself and someone else. Dreams accept superposition without question. They flow with it. They breathe it. And so, as you drift into your own dreams tonight, you may find yourself carrying the same softness, both asleep and awake, both present and wandering, both listening and letting go. Superposition reminds us that reality itself is more than a single line. It is a tapestry woven from many threads. Only when we look closely does one thread stand out, but the whole pattern is always there. Quiet, rich, infinite. So tonight, let yourself rest in that tapestry. Let yourself be both body and breath, both thought and silence, both here and far away. Like the particles themselves, you are not limited to one truth. You are many. You are possibility. You are superposition. There's a quiet phenomenon in the quantum world, so strange, so delicate, that even Einstein himself once called it spooky action at a distance. It is known as entanglement, and it tells us that particles, once connected, can remain linked no matter how far apart they drift. Imagine two dancers who begin side by side, their steps in perfect harmony. Now imagine they drift to opposite sides of a vast stage, yet somehow, when one turns, the other turns too instantly, without hesitation. In our world, this seems impossible. How could one know what the other is doing across such distance? And yet in the quantum world, this is how entangled particles behave. When two particles interact in just the right way, they form a bond not of matter, but of information. They become part of one shared state. If you measure one, you instantly know something about the other. It does not matter if they are across the room or across the galaxy. Their connection is invisible, yet unbroken. This has been tested again and again in delicate experiments. Physicists create pairs of entangled photons and send them flying in opposite directions. No matter how far they travel, when one is measured, the other state is revealed instantly. It is as though the universe itself refuses to let them forget each other. At first, many thought there must be a hidden explanation. Perhaps tiny signals travel between them, faster than light. Perhaps there are unseen variables guiding their steps. But over time, the experiments grew sharper, the tests more precise, and again, the results showed the same quiet truth. The link is real. Entanglement is not a trick. It is the way the quantum world holds things together. If you try to imagine it, picture a pair of twins who share not only memories, but choices. Even if they stand on opposite sides of the earth, when one smiles, the other feels a warmth. When one frowns, the other senses a shadow. Not because of a message carried across space, but because they are woven together in a way deeper than distance. This invisible weaving has begun to shape new technology. Quantum cryptography uses entangled particles to create codes that cannot be broken. Quantum teleportation, tested in laboratories, transfers information between particles instantly across space. What once sounded like science fiction now grows slowly into science fact. But beyond the machines and mathematics, entanglement carries a softer message. It tells us that separation is not absolute, that even across vast distances, there can be bonds that endure. It whispers that the universe is more connected than it appears. Perhaps you can feel this truth in your own life. Think of someone you love, someone far away. You do not see them each day. Yet sometimes you sense their mood, you think of them at the very moment they think of you. Science may not call this entanglement, but the feeling is the same, a reminder that connection can stretch across distance, quietly, invisibly. And so, entanglement is not only a puzzle for physicists, it is a lullaby for the soul. It says that the world is not a collection of isolated pieces, but a web, a net of relationships, threads, and ties. What happens to one ripples through the whole. As you lie here tonight, listening softly, perhaps you can imagine yourself as part of that web, a single particle, yet connected to countless others. Your breath touches the air. Your thoughts ripple outward. Your being is not alone. Just as entangled particles remain linked, so too do we remain linked to each other, to the universe, to all that is. The mystery of entanglement grows even more fascinating when we pause to consider how it challenges our picture space and time. In our everyday world, we think of events as local. If you flip a switch, the light turns on because of wires and circuits. If you drop a pebble in water, the ripples spread outward in circles. Every cause has an effect, carried through space, step by step, moment by moment. But entanglement does not wait for ripples. It does not send signals through wires or waves. The moment one entangled particle is measured, the other reflects that outcome instantly, no matter the distance. This instant connection seems to step outside our usual sense of time and space, as though the particles are not truly separate at all, but still part of one shared whole. Einstein struggled with this. He believed that no influence could travel faster than the speed of light, and yet experiments kept pointing toward this spooky action. For him, it felt incomplete, as if nature were hiding something. But over the decades, careful tests showed again and again there is no hidden mechanism. Entanglement is real. The universe, at its deepest level, is bound together in ways that defy ordinary separation. To picture this, imagine a delicate pair of dice, crafted so perfectly that no matter how far apart they're rolled, they always land showing numbers that match a secret rule. Not because they communicate as they tumble, but because they were born from the same pattern, the same mold. Entangled particles are like those dice. They are not two independent things, but expressions of a single shared state. This truth carries profound meaning. It tells us that the smallest threads of reality are not isolated dots, but woven strands. Each particle holds not only its own possibilities, but also those of its partner. To touch one is to touch the other. To measure one is to shape the fate of the other. Modern experiments stretch this even further. Entangled particles have been sent miles apart, across mountaintops, through open skies, and even from Earth to orbiting satellites. And still the link remains. Distance does not fray it. Time does not weaken it. The connection is as immediate as ever, as though space itself is not a barrier. This has opened dreams of new technologies. A quantum internet built on entanglement could connect distant places with perfect security. Information could be shared not by wires or signals, but by invisible threads that cannot be broken or spied upon. It is as though we are learning to play softly with the hidden chords of the universe. And yet, even with all this, the heart of entanglement remains mysterious. Why does it work this way? Why should two particles, once joined, remain bound beyond distance? Physics described the how, but the why remains wrapped in silence. And perhaps that is part of its beauty. Some truths of the universe are not only equations, They are quiet mysteries that ask us to wonder. If you pause, you may feel that entanglement is not so alien after all. Think of the bond between parent and child, between close friends, between hearts that have touched. No matter the miles, the connection lingers. A thought, a memory, a quiet feeling. You carry part of them, and they carry part of you. This human entanglement may not be measurable in the laboratory, but it feels just as real. And so, when you think of quantum entanglement tonight, you may imagine more than particles of light. You may imagine threads of connection weaving through your own life, threads that bind you to others, to places you've been in, moments that have shaped you. Like the particles, you are never truly alone. You are part of something larger, something shared. As you rest, perhaps you can feel those threads now, gentle, invisible, stretching softly across time and space, linking you to those you love, to the world around you, to the universe itself. Quiet, unbroken, eternal. Entanglement is perhaps one of the most poetic truths in all of physics, because it tells us something we often feel but cannot explain, that at the deepest level, separation may be more of an illusion than a fact, that threads of connection exist beneath what our eyes can see, weaving particles, people, and places together. Physicists describe entanglement in precise equations, in wave functions that spread across space. But when we step back and listen not with calculation, but with wonder, what we hear is a story of unity. Two particles, once touched, never truly part. Their destinies are written together. Their possibilities are shared. No matter how far they travel, the bond endures. Imagine starlight crossing the sky. Each photon that reaches your eye began its journey countless years ago, from a star so far away that its light has crossed the oceans of space to find you. Some of those photons may even have traveled entangled with others, their fates still bound across the cosmos. When you look up at the night sky, you may be gazing not only at distant suns, but at silent threads of entanglement stretching between you and the stars. And if particles can be so deeply connected, perhaps the same is true of us. Our lives, too, are not lived in isolation. We are shaped by every word spoken to us, every hand held, every glance of kindness. These moments bind us, invisibly, into the web of one another's lives. Entanglement in physics may be measurable only in the lab, but entanglement in the heart is something we all carry. It is gentle to think of it this way, that no connection is ever truly lost. Just as entangled particles remain linked across distance, perhaps the bonds we form with others remain, even across years, even across silence. A part of them stays with us, and a part of us stays with them. Always, this quiet truth can ease the loneliness we sometimes feel, because beneath the surface of separation, there is togetherness. Beneath the silence, there is connection. Beneath the space between us, there is unity. Quantum entanglement has even been described as a kind of cosmic glue, not a glue of matter, but a glue of information, of shared being. Without it, the universe would be less whole, less woven. With it, reality itself feels like a single vast fabric, where pulling one thread gently tugs on the entire cloth. And so, as you listen now, in this quiet moment before sleep, you might picture yourself lying gently within that fabric. The air that touches your skin, the breath you take in, the starlight that falls upon the earth, all of it is part of the same woven whole. You are not apart from it. You are inside it, entangled with it. As your thoughts drift softer and slower, let yourself rest in this truth, that you are connected, that you are part of the same music as the stars, the same dance as the smallest particles, the same endless web that holds all things. Entanglement is not only a puzzle for physicists, it is a reminder that nothing exists alone, not the particles of light, not the people of the world, not even you resting here tonight. We are bound together, softly, invisibly, forever. And so, with this thought, you may let your eyes close. You may let your breath settle. You may drift into dreams carried by the quiet comfort of knowing you are entangled with everything. Beneath everything you see, beneath particles, beneath atoms, beneath even the smallest sparks of light, there is something deeper. It is called the quantum field, and it is the invisible fabric from which reality itself is woven. In the early days of physics, scientists thought of particles as tiny, solid marbles, little beads of matter moving through empty space. But as experiments grew more delicate, they revealed a softer truth. The universe is not built from particles floating in a void. It is built from fields, invisible oceans of energy that stretch across all of space. Imagine an endless sea, calm and still. Now imagine tiny ripples forming on its surface, waves rising and falling. Those ripples are what we call particles. The sea itself, that is the quantum field. Everything we see, everything we touch, is just a ripple on that deeper ocean. There is not only one field, but many, a field for electrons, a field for photons, a field for quarks, the building blocks of protons and neutrons. Each particle is not a separate thing, but an excitation of its field, a temporary wave on an endless surface. This is not just imagination. It is the heart of quantum field theory, the framework physicists use to describe the universe. In this picture, even empty space is not truly empty. The fields are always there, humming quietly, filled with energy that never vanishes. The vacuum of space is alive with possibility. To make this gentle idea easier to picture, think of a blanket stretched across a bed, smooth, soft, unbroken. If you press it with your hand, a ripple forms. That ripple is like a particle. But the blanket was always there, supporting it, holding it, stretching far beyond what you see. The quantum field is like that blanket, and the particles we notice are simply the ripples it carries. This view changes how we think about reality. Instead of particles as little dots bouncing around, we see them as patterns in something deeper, patterns of vibration, patterns of energy, like notes in music. They are not separate things, but expressions of an instrument that is always present. And this instrument, this field, is everywhere, right now. It fills the room around you. It fills the space within your body. It fills the sky, the earth, the distant stars. Every point in space is alive with these fields, and every particle that exists is a gentle ripple in them. Even what we call mass, the heaviness of matter, comes from a special quantum field, the Higgs field. Without it, particles would not have weight, and the universe would be formless. It was a discovery of the Higgs boson, a ripple of that field that confirmed this hidden fabric, the fabric that gives shape to all things. There is something calming in this thought, that beneath the changing, shifting, flickering world we see, there is a field that holds it all, quiet, steady everywhere, a presence that does not vanish when particles fade, but remains soft and eternal. Perhaps you can feel it now, like a background beneath your thoughts, beneath your breath, beneath the silence of the night. The quantum field, the ocean beneath reality, supporting you, surrounding you, carrying you always. The more we reflect on the quantum field, the more it begins to feel less like a scientific theory and more like a quiet truth of existence. For the field is not somewhere far away. not tucked in laboratories or hidden behind equations. It is here and now, in this very moment, surrounding you, moving through you, shaping everything you see and feel. When physicists speak of the quantum field, they describe it as continuous, stretching endlessly across the universe. Unlike particles, which appear and vanish, the field is always present. It cannot be switched off. It is the stage on which all reality performs, and also the silent music that fills the stage itself. This means that what we think of as empty space is not truly empty. Even in the vast dark between stars, even in the vacuum of intergalactic space, the fields are alive. They ripple with faint fluctuations, little sparks of energy that appear and disappear, a restless hum that never fully goes away. This background activity is sometimes called the zero-point energy. To us, it may seem like nothing at all, but to the universe, it is the foundation of everything. To help you picture this, imagine a still pond at night. To the eye, it seems calm, flat, silent. But if you lean closer, you may notice tiny ripples gliding across the surface, born from fish beneath or the brush of wind. The pond is never truly still, just as the quantum field is never truly quiet. Even in silence, there is motion. Even in emptiness, there is life. And when enough energy gathers in the field, a particle emerges, not as something separate, but as the crest of a wave, the sparkle of a ripple. When the wave settles, the particle is gone, but the field remains, always beneath, always supporting, always present. This idea reshapes our understanding of reality. It suggests that matter itself is not the bedrock of the universe. Matter is not the final answer. The fields are deeper still, invisible but eternal, carrying potential for all things. In this view, you are not a collection of separate particles, scattered and isolated. You are a pattern in fields, a gentle ripple of energy woven together into thought, breath, and being. Just as a song is not separate from the air that carries it, you are not separate from the fields that carry you. The Higgs field, in particular, gives us a glimpse of how essential these hidden fabrics are. Without the Higgs field, particles would never gather mass. Without mass, there would be no atoms. Without atoms, no stars, no planets, no people. The very weight that anchors you to the earth, the very solidity of your body, comes from an invisible field humming quietly through all of space. And this is true not only for matter, but for light itself. The electromagnetic field is what allows photons to travel, what allows radio waves, microwaves, and visible light to shimmer across space. Every sunrise, every rainbow, every glimmer of starlight is the song of a quantum field playing out across the cosmos. So the next time you gaze at the night sky, perhaps you can imagine it differently. Not as stars scattered in emptiness, but as ripples on an endless sea. A sea of fields alive, silent, infinite. The stars are not floating in nothingness. They are woven into a fabric that stretches everywhere. There is comfort in this picture, because if the quantum field is everywhere, it means you are never truly separate from the rest of the universe. The same fields that ripple within your body ripple within the stars. The same ocean that carries your being carries the galaxies. You are not apart from it. You are of it. And so, when you breathe in and breathe out, you may imagine yourself breathing with the fields, breathing with the same hidden currents that have existed since the dawn of time, a quiet harmony, a shared rhythm, a reminder that you are not only in the universe, you are part of its very fabric. When we reach the idea of the quantum field, it can feel as though we are standing at the edge of something vast, a truth both scientific and deeply poetic. For in these fields, stretching silently across all of space, we glimpse the hidden fabric of reality itself. Physicists often say that the quantum fields are fundamental, more fundamental than particles, more fundamental even than the stars. The fields do not come and go. They do not appear and vanish. They simply are, always there, always humming, always carrying the possibility of everything that could ever exist. Imagine a violin string waiting in stillness. When touched, it sings. When left alone, it is silent, but its music is still there, waiting, hidden in the tension of the string. The quantum fields are like that, always present, always ready to sing reality into being. Every particle is a note, every interaction a melody. The whole universe is the song of the fields. This way of seeing the world softens our sense of separation. It reminds us that the stars, the galaxies, the atoms of your body are not separate building blocks scattered in a void. They are ripples in the same endless ocean, patterns in the same unbroken fabric. When you look at your hand, you are seeing fields made visible. When you look at the night sky, you are seeing the same fabric stretched across infinite distances. And even what we call empty space is not nothing. It is alive with fluctuations, with tiny sparks of energy rising and fading. Too brief for us to notice, yet essential for balance of the cosmos. The vacuum, as physicists call it, is not emptiness at all. It is fullness, a quiet fullness that holds the seeds of everything. There is something deeply calming in this thought. To know that beneath all change, there is something unchanging. Beneath all motion, there is something steady. Beneath the ripples, there is always the ocean. The quantum fields are that ocean. Silent, eternal, infinite. Some physicists even wonder, could consciousness itself be linked to the fields? Could our thoughts, our awareness, be part of this deeper fabric? The science is still uncertain, and perhaps always will be. But it is a general idea to hold, that even our inner lives may be ripples on the same vast sea that gives rise to stars. So tonight, as you listen and rest, you may imagine yourself floating on that sea, not as something separate, not as a lone particle adrift, but as part of the fabric itself. The field is beneath you, around you, within you. Every breath is carried by it. Every heartbeat is shaped by it. You are not apart from the quantum field. You are the field, expressed for a little while as you. Let this thought ease you. Let it settle into you like a lullaby, that you are safe within the fabric, that the field holds you as it holds the stars, as it holds the galaxies, as it holds all of time and space. You are part of something vast and eternal, and it will always carry you. In our daily lives, the world feels solid, predictable, and certain. If you drop a cup, it falls. If you open a door, it swings on its hinges. The sun rises, the moon glows, the seasons shift with steady rhythm. This everyday world obeys what we call classical physics, rules of motion, force, and gravity that are simple to see and trust. But beneath this familiar surface lies the quantum world, and its rules feel very different. In this hidden realm, particles behave like waves, existing in many places at once. Outcomes are uncertain until measured. Entangled partners remain linked across vast distances. Superposition allows a single particle to be both here and there. Why does the world we see feel so different from the world beneath? Why does the quantum world shimmer with strangeness, while the everyday world feels steady and clear? Physicists believe the answer lies in scale. Quantum rules govern the tiniest parts of reality, electrons, photons, atoms. But as countless particles gather together, their quantum behaviors blur into averages. The uncertainty fades into predictability. The superpositions collapse into solid outcomes. The strangeness is still there, but hidden, smoothed out into the patterns we call ordinary life. It is like watching the ocean. Up close, every drop of water moves unpredictably, shifting and swirling. But when you step back, you see waves rolling in steady rhythm, tides rising and falling with calm order. The ocean's chaos becomes beauty. The quantum world is like those drops, strange, wild, uncertain. Our everyday world is like the waves, steady, patterned, familiar. Still, the mystery remains. Why does the act of measurement matter? Why does observation transform uncertainty into certainty? Why does the universe keep its strangest truths hidden until we look? These are questions science still wrestles with. Some say the wave function, the cloud of possibilities, collapses when observed. Others say the possibilities continue, branching into parallel worlds we cannot see. No one yet knows for sure. And perhaps that is the heart of Keynote 10, the mystery. The quantum world is not just strange. It is humbling. It reminds us that reality is deeper, subtler, and more surprising than our eyes alone can grasp. It tells us that certainty is not the foundation. Mystery is. For you, resting here tonight, this can be a comforting thought that beneath the routines of everyday life, there is wonder beneath the solid floor, the steady walls, the ordinary clock ticking. There is a hidden world of waves and possibilities, a secret layer of magic, humming quietly, unseen yet always present. And maybe that is why the quantum world feels so different, because it is not here to follow our expectations. It is here to remind us that the universe is larger than our understanding, that certainty is only part of the story, and that mystery is not something to fear, but something to embrace. So as you drift into dreams, let yourself rest in this mystery. The quantum world may never fully reveal its secrets, but its strangeness is also its beauty, a quiet invitation to wonder and to dream. And so, dear listener, we have traveled together through the quiet mysteries of the quantum world. We have explored particles that are waves, waves that are particles. We have drifted through the wonder of uncertainty, the strangeness of superposition, the invisible threads of entanglement, and the deep oceans of the quantum fields. We have seen how measurement shapes reality, how particles slip through barriers, how quantum rules shape the technology we use each day, and finally, we have rested in the mystery of why this hidden world feels so different from our own. Perhaps, as you listen, you feel a little closer to the fabric of the universe. Perhaps you sense in some gentle way that you are part of the same quiet wonder, a ripple in the cosmic sea, a note in the endless song of existence. The quantum world does not give us all the answers. Instead, it reminds us that there will always be mystery, always more to explore, always more to dream. And maybe that is the most comforting truth of all, that the universe is not finished, and neither are we. So tonight, as you rest, may you carry these gentle thoughts with you into your dreams. May you feel calm, safe, and softly connected to all things. May the mystery of the universe surround you like a warm blanket, steady, quiet, eternal. Thank you for sharing this time with me, here in the Bedtime Discoveries. Until we meet again, I wish you peace, I wish you stillness, I wish you rest. Good night and goodbye.